The topic that we are going to discuss is functions. We would define functions in terms of relations. So let A and B be two non-empty sets, and let R be a relation from set A to B. Then the relation R is called a function from set A to B if for every x in A there exists a unique element in B, y, such that x is related to y. If x is related to y as well as x is related to z, then y and z must be same. Thus, if f is a function from a set A to B, then f is nothing but a relation from A to B with additional conditions mentioned above. How to write a function in symbols? So let's say f is a function from A to B. Then function f is written as this: f A to B. It is read as f is a function from A to B. Now suppose x is a member of A and y is a member of B, such that x is associated to y under the rule f. Then we write fx equal to y, or we call it f of x equal to y. And here x is called pre-image of y and y is called image of x. So if f is a function from A to B, then f is a rule which associates each element of set A to a unique element of set B. Here we have taken two sets A and B, and we have defined f as this: f of x equal to q root of x. So here if I take 8, then 8 will be associated to q root of 8. So 8 is associated to 2, 27 is associated to 3, 64 is associated to 4. So here we saw that under this rule f, each element of set A is uniquely associated to the elements of set B. Now we will discuss the following terms: domain, range, codomain, image, preimage. For this we have taken two sets A and B, and we have defined f from A to B such that f of x equal to q root of x. So f of 8 is equal to 2, f of 27 is 3, f of 64 is 4. This is the diagram form. Now domain of f. So domain of f, so here our f is a function from A to B. So domain will be the first set A. Okay. Range of f. So range of f will be collection of the images. So here in image we have 2, 3, 4. 2, 3, 4. Codomain of f. So codomain of f. So here our function is f from A to B. So codomain is the second set B. So whole of B is the codomain of set function f. Image is clear. Like here 2 is called image of 8, and 8 is called pre-image of 2. Same way 3 is image of 27 and 27 is pre-image of 3. 64 is pre-image of 4 and 4 is image of 64. Examples. Here I have taken two sets A and B, and f is defined from A to B, and the definition is this: f of x equal to x square. So clearly for each element under this rule we have unique image. So this is a function. Here in example 2, f is defined from A to B, and the f is defined as this: f of x equal to square root of x. Clearly for each element in set A we have unique image in set B. So this is also a well-defined function. Next, f is defined from A to B, and this is how we have defined f of x equal to x plus 1 upon 2. And here also we see that every element of set A has unique image in set B. Example 4, here f is defined from A to B, and definition is this: f of x equal to x square. Clearly under this rule each element of A has unique image. Like -2 has got image 4, it has got one unique image. This 2 has got unique image 4, 1 has got unique image, that's 1, 0 has unique image, that's 0, -1 has unique image, that's 1. So this is also a well-defined function. Next, example 5, here from set A to B we have defined f's such that f of x equal to x square. So here for 1, f of 1 will be 1 square, that is 1. So clearly this 1 has got unique image under f, 2 has got unique image under this, 3 has got unique image under f, but 4 does not have any image. Okay, f does not have an image, so this is not a well-defined function. Now sixth example is here f is defined as this. Here 2 is associated to 4 as well as 8. So this element of set A has got two images under this function f, under this rule f. So this f is not a function because here 2 does not have unique image. Hence this violates the definition of function. Hence f is not a function. Next, types of functions. First one is 1 1 function. So if we have a function f from A to B, then we would say that this function is 1 1 if no two elements in A have same image. So here we can see in each example over here, no two elements of set A have same image. Therefore, these are the examples of 1 1 function. Many to one, if we have a function f from A to B, then it is said to be many to one if two or more than two elements have same image. So here in each example you see that two or more than two elements are associated to a single element of set B. Like here -2 and 2 both have same image 4. Here 0 1 2 have same image. Here 4 and 6 they have same image. So this is called many to one. Into function. If we have function f from A to B, then this is called into if there is at least one element in B which is not image of any element of A under the rule f. So in this example, if you see -2 does not have an image pre-image under this rule F. 1 does not have preimage, 2 does not have preimage, so this is into function. Same goes with this -1, 0 and 25. They don't have preimage. Here 0, 1, 7, they don't have preimage. So these are the examples of into function. Next comes onto or surjective function. So if we have a function f from a to b, then f is called onto function if every element in b has at least one preimage. So every element in set b must have preimage. So these are the examples of onto functions. Here we can see that in set b, 0 and 1 both has got preimage. Here 7 and 8 both has preimage. Here 1, 2, 3, 4, all these four elements of set b have preimage. So these are the examples of onto functions. Now 1 onto, we also say bijective function. So if a function f is from a to b and f is 1 as well as onto, then we say that f is bijective. Here if we see, no two elements of set A have same image, so f is 1 and every element of set B has got preimage, so this is onto also, so f is bijective. Next is identity. Let A be a non-empty set, then we define a function f from a to a such that f of x equal to x for every x in A. So if we can have a function like this in the same set, then we say that function is identity. Here the example is A has elements 1, 2, 3. So here we have defined function in such a way that 1 is getting linked to 1, 2 is getting linked to 2, 3 is getting linked to 3. So this function is an identity function. Next is equal functions. Two functions f and g are said to be equal if, number one, they have same domain, and secondly, f of x equal to g of x for every x in their domain. So here we have taken two examples. Here we have taken two sets of functions f and g. F is from a to b, g is also from a to b. So here clearly we can see that domain of both the functions f and g, a, that is a, so it's same. Now we observe that f of 2 is 7 and g of 2 is 7. So we observe that f of 2 is equal to g of 2. Okay, and same way f of 3 is equal to f of g. So here both the conditions are satisfied by these two functions. So these two functions are equal to each other, and they are called equal functions. Next, constant functions. Suppose we have a function from a to b. Suppose f is a function from a to b, then we would say that f is a constant function if every element of a has same image in b. Like here I have taken two sets a and b, and f is defined such a way that f of x equal to 7. So here we see that each element of set a are getting linked to same element in set b. So clearly every element of a has same image, that is f of 1 equal to 7, f of 2 equal to 7, f of 3 equal to 7. So that means f is a constant function. Real valued function. If a and b, suppose we have two sets f a and b, and they are non-empty subsets of set of real numbers. So they are non-empty and they are subsets of real set of real numbers. And then we define a function f from a to b. Then this function will be called real valued function or real function.